And we need to make a turn, obviously. And keep going. And you can see how it's being updated. This little device knows where I want to go, and it shows me direction to the next waypoint. No phone, no screen, just a servo arm spinning and showing me the way to go. Let me show you how I built it, and why the first version completely failed. As a part of building my own future navigation system, I got my hands on a GPS and a compass module. It combines two useful sensors into a small package: GPS for positioning and a compass for heading. So before putting it into a vehicle, I decided to build a small project, the navigation system, for myself. So this is the module I'm talking about. Yeah, basically this is the GPS antenna, and the module requires 5 volts as power and produces UART outputs for GPS and I2C for the compass. It's worth mentioning, even with 5 volts being the power for the device itself, the data lines are 3.3, so we can connect them directly to either Pico or ESP32. So I designed and 3D printed this device to hold everything together. Basically, the sensor itself is connected through a plug and then goes here. The idea for this device is to keep the sensor far away from the servo and at some distance from ESP32. In this particular case, this is a Legu Carbon ESP32. And this whole thing is being powered through a USB bank. So it's convenient for me to carry it with me in the car or in other vehicles. This is the source code for the GPS tracker itself. I will explain later the very simple math behind it, but the core of this code is the list of waypoints we're going to follow. These waypoints I took from Google Maps. For example, if I just drop a pin somewhere here, you can see the coordinates appear. And I basically took a few waypoints in a friendly neighborhood. With a magnetic compass, we know where the north is. So let's draw it. And since our sensor has a compass as well, when our device rotates, we can see the angle or the bearing where we are facing. In this particular case, roughly 330 degree. Now we're going to assume our waypoint is somewhere here, and we know our own coordinate from the sensor itself. So now we can get bearing to our waypoint, assuming the Earth is not flat. And in this particular case, we can see that the bearing is 30 degree. And now we know how much we need to turn our servo to be able to walk to our first endpoint. And as we will be approaching to the endpoint, and we will be within 5 meters, we're going to switch to the next endpoint. And this way we'll be able to go through all waypoints we have in our code. After the code is being uploaded to the device, it's time to power it up. And after the power is on, you can see that the servo goes into neutral position. And now we need to rotate the device 360 degrees to make sure the compass is calibrated. Blinking green means that we have GPS coordinates from the satellites, and the system starts pointing to the first waypoint. So now if I'm gonna go this way, it keeps rotating, and if I'm gonna put it the other way, we kind of go the same direction. Okay. And now it's time to try it outside. This is test from a different angle, basically from there. So I'm going to give the power and calibrate it again. And I don't have enough hands, so... Okay. So our intersection and our direction. Yeah, that's the point I kind of selected. So let's walk.
and we need to turn here. So let's say we are going to turn. And that's our path forward. In 2 intersections, that direction, there is another turn, but I'm not going to walk that way.
And then I got into my car, put the device on my dashboard, mounted the camera and decided to drive around. And you can see how the device is completely dead. It does not show me the turns, it does not change anything. And actually at some point it became like a random number generator. I spent some time looking for a software bug, but I was lucky to have my compass with me.
Now I'm going to move it here. The compass changes. And you can see just moving it in the car. Okay, so when I was standing, everything was fine in this area, but not anymore.
Clearly, the compass is not working in the car, so my idea of having my bearing based on the compass was not going to work. So I had 2 options here. One was to write a better software, or the second one was change the vehicle.
We're gonna use it on a bicycle.
So before solving this problem for the car, I decided to just use my bike. My bike has electronic shifting, but it does not affect compass in any way. The device was working perfectly on my bicycle, so I decided to fix the issue for the car. And since I cannot use my magnetometer in the car completely, I decided to switch to GPS only bearing. I decided to use a very simple approach. I check my current coordinate and coordinate which I had 1 second ago and calculate my bearing from those 2 points. To test GPS, I left the GPS on for 2 minutes and I recorded coordinates every second and put the data as a CSV. After the data was available, I decided to plot it to see how much drift we have. So you can see a latitude drift up to 2.5 meters and the longitude basically goes as far as 6.5. These are basically the data here. And the coordinate itself, if we'll check the mean of all the points I've collected, that shows how far we go from the middle of all data we have. And we basically see that the average drift is roughly 2 meters. With the GPS data drift, I decided to change my approach. Instead of relying on a single reading, I averaged the most recent second of data for my current position and the second before that for my previous position. That gave me 2 clear points to compare, which produce a reliable estimate of the direction I was actually moving. And once I used that movement direction instead of the compass, everything started working without any issues. I was able to drive the whole route and hit every single waypoint.
Here we are. Nice.
So I'm glad I started this project as an experiment and did not put this into my RC model directly. Car can drive themselves, boat can navigate on their own, and eventually things will fly themselves. So if you're interested in all of this, please subscribe. And thank you for watching.